Now, one thing which is very much clear in this class diagram is that the subject and the observers are not tightly coupled. So, observer design pattern caters to the loose coupling as well. Now, let's explore this loose coupling aspect a bit more. When two objects are loosely coupled, they can interact but have very little knowledge of each other. So, observer pattern provides an object design where subjects and observers are loosely coupled. How they are loosely coupled? The only thing the subject knows about an observer is that it implements a certain interface. Let's go back to the class diagram and see. In this case, the observer interface. It doesn't need to know the concrete class of the observer, what it does, or anything else about it. We can add new observers at any time because the only thing the subject depends on is a list of objects that implement the observer interface. We can add new observers whenever we want. In fact, we can replace any observer at runtime with another observer, and likewise, we can also remove any observer at runtime. The subject will not get affected by that. We never need to modify the subject to add new types of observer. Let's say we have a new concrete class come along that needs to be an observer. We don't need to make any changes to the subject to accommodate the new class type. All we have to do is to implement the observer interface in the new class, and then we simply register as an observer or attach as an observer. The subject doesn't care. It will deliver notifications to any object that implements the observer interface. Like YouTube channel will deliver notification to any subscriber who will press the bell icon. It has nothing to do with who the subscriber is, what he do, what other channel he subscribed to, and all that. And if any user of the channel will anytime gets desubscribed from the bell notification, then again the YouTube channel won't get affected by it. We can reuse subjects or observers independently of each other. If we have another use for a subject or an observer, we can easily reuse them because the two are not tightly coupled. Changes to either the subject or an observer will not affect the other. So, as a pattern, observer design is useful. It works in different scenarios and it becomes so popular that Java launched its own API for this pattern. java.util.Observable class and java.util.Observer interface. But as of JDK 9, both are officially deprecated. This means that they are no longer recommended for use in the new code. The reason for deprecating these classes is that they have several design limitations and issues. For example, observable is a concrete class, which means that any class that wants to be observable must inherit from it, potentially limiting inheritance options because Java allows only a single class inheritance. Additionally, observer is an interface with a single method, which can be limiting in terms of flexibility and extensibility. So, as an alternative, it is recommended to use the observer pattern in a more flexible and extensible way, such as by defining your own custom interfaces and using them to implement the pattern, like implementing this class diagram in your own design. But then there are certain different alternatives as well. You can use third party libraries that provide a more robust implementation of this pattern. Like now we use property change listener interface in case of Java Beans, and there are other event driven mechanisms and APIs available. We use reactive extension RxJava, a library that provides reactive programming model and that allow us to observe and react to changes in the data stream such as user input or data from server. We also use events and listeners. We are using them for such a long time where The events are emitted by a source object and listeners register to receive those events. And we are doing all that with the swing and Java beans. Then we have the callbacks. Callback is a function that is passed as an argument to another function, and it is called when a certain condition is met or some event happens. So, in case of asynchronous programming, we can use the callbacks. And similarly, we can use the completable future class, which is used for asynchronous programming again. It runs a task on a separate thread than the main application thread and notifies the main thread about its progress, completion, or failure. And then Java 8 Stream API provided a way to process collection of data in a functional and declarative way. They can be used to observe and react to changes in the data streams in a similar way to Rx Java. So, reactive programming, callbacks, stream, events, listener, there are n number of ways to have this pattern in use. Because, again, observer design pattern is a useful design pattern and it has lots of real time applications in our system.